Hey, this is our Van de Graaff machine. We are still tweaking it and things, but we are pretty much done with the construction. A Van de Graaff machine is basically a static electricity generator. Um, Generates a high voltage. If you've ever been to a science center that has one, you know what they are. They have you generate an arc across something. Um, Either your hand or some other thing. Um, so the way a Van de Graaff machine works is you have a roller on the bottom and a roller on the top and a belt that goes in between the two and transfers the electricity or the electrons from
the
one
bottom to the top.
Basically from our ground, which is a piece of aluminum, transfers the electrons through the wire up through this pickup and then onto the belt, and then at the other end the pickup here transfers the electrons
into the ball right here.
The ball, which goes on the top. The roller materials are very important. They need to be on opposite ends of the triboelectric
series Graaff.
The one down here is made out of acetyl,
and this top one is of Teflon.
So we have all this. All the pieces were cut out on the CNC machine. We have a.
There it is, the CNC machine.
We have a 12-volt DC motor, which is driven through a belt, which drives the roller.
The
some
bottom
bearings
one
here. We turn the shafts for the thing on the lathe. We found an old power supply that we use to power the thing, which
plugs in perfectly.
Outlet, and then
we have a potentiometer back here. If I can get the ball out of the way. Here's our potentiometer. And here is the plug that goes to the adapter right here.
Okay, so if we turn it on, you can see the belt rotating.
And it can go significantly faster than that.
And then the ball fits on the top.
Like that.
Took a lot of cutting to get it to fit over things. It's kind of squat looking when you...
Yeah, it looks kind of ridiculous.
So... The pickups are made out of
this copper meshy stuff over here, this big roll. And we have two of them way up in there. And the reason that we have the top roller inside this ball is because it's better to do that so you don't get corona discharge, which can suck away all your precious, valuable, high-voltage charges.
That's kind of an overview.
And now we get to turn it on and shock ourselves. So let's go and do that. The reason that this doesn't kill you, because it's at over 400,000 volts, at least a well-made one is. We don't know whether this one is well-made yet. But the reason that it doesn't kill you isn't because volt-jolts current kills. That's wrong. It's because this is over a very short time. The current can be over 40 amps, and the voltage is, as I said, 400,000 volts or higher. But the energy is extremely low because of the time. It's less than a nanosecond because... And energy is what really kills you in this with high voltage, because energy is it includes voltage, current, and time. So this has both very high voltage and very high current, but not high time. And energy is what can kill you. We're going to turn the lights off so that we can see the art better. What? Happened? I don't know. Happened, but the motor isn't working anymore, and I found this set screw attached to it because there's a magnet in the motor. So we don't know what's going on. We're going to try to figure it out off camera. Apparently, it was actually the adapter that died here, and it was a little bit weak for our setup down here. And right now, we're running it off our power supply. It's turned off because the potentiometer down there is all the way down to 0, but it does work. As you can see, it's working. So we fixed it. Good. Whoa, that was powerful. If you get your hand closer, then you'll get a bunch of tiny sparks. Happy that the first model seemed to work, although it did have some issues, like the belt not being able to stay on this bottom roller very well, and it not reaching higher enough voltages for us, and this potentiometer not doing its job correctly because it did break on us, and a few other problems, and we'll be fixing those later. But this is the end of the video, so bye.